Okay, now we are multiplying complex numbers together, and we always want to leave the answer in standard form. That is the form a plus bi. And that means that if you have an I squared anywhere in your answer, don't leave it like that. Remember that I squared is -1. Okay, here we go. First example, 5i times -3i. So we've got a 5 times a -3, which is 15, times an I times another I, which is I squared. And remember what I just said? I squared is -1. So this is -15 times -1, which is +15. Remember, a negative times a negative is positive. So -15 times -1 is +15. Next example, 4i times the number 1 plus 9i. Think in terms of the distributive property. The 4i is going to get multiplied by both terms of the 1 plus 9i. So we've got 4i times 1 plus we've got 4i times 9i. Now let's see what happens with each of these. 4i times 1 would just be 4i. And then 4i times 9i would be 36i squared. The 4 times the 9 is the 36, and this I times this I is I squared. But we don't want to leave it like this. We don't want to leave it with an I squared. We want to make that I squared just turn into -1. So now it's 4i plus 36 times -1, which would be -36. And the part without the I, we'll write that in front. So we've got -36 plus the imaginary part, the part that is next to the I, we'll put at the end. So we'll write it as -36 plus 4i. So there's our standard form, our real part, and our imaginary part times I. Next example of multiplication, 7 minus I times 2 minus 5i. This one you can think of doing the FOIL method to multiply it out. Multiply the first, the outer, the inner, and the last terms. So first we have 7 times 2, that's 14. On the outside we have 7 times minus 5i, so that's minus 35i. On the inside we have a minus I times a 2, so that's minus 2i. And last we have a minus I times a minus 5i, so that would be plus 5i squared. And now combining like terms in the middle here, we have 14 minus 37i, and then remember I squared is -1. So this 5 times this -1 is -5 or minus 5. Finally, we can combine the 14 minus 5 into 9. So we end up with 9 minus 37i. So that's the answer in that standard a plus bi form. We got 9 minus 37i. Oh, by the way, if you have a graphing calculator, not just a plain old scientific calculator, but a graphing calculator, you might be able to ask your calculator to do this for you. Here's what it looks like. I'm going to put in parenthesis 7 minus I, close parentheses, times parenthesis 2 minus 5i, close parentheses. Did you see how I get those i's? It's a little hard to see, but above the decimal point button, there's a little blue letter I there. So if I push the second button and then that button, that makes the I appear. So I'm asking my calculator to multiply 7 minus I times 2 minus 5i, and when I hit enter, it comes up as 9 minus 37i. So the calculator agrees with what we got. Okay, on to the next example. We're multiplying 3 plus 2i times 2 plus 4i. Again, FOIL this out. First, we have 3 times 2 is 6. On the outside, we have 3 times 4i is 12i. On the inside, we have 2i times 2 is 4i. And last, we have 2i times 4i is 8i squared. Now combine the I terms and rewrite the I squared as -1, and we get 6 plus 16i minus 8. Then we can combine the 6 minus 8 into minus 2 plus 16i. So that's our answer in standard form, -2 plus 16i. Now how about 10 minus 6i times 10 plus 6i? Multiply this out. 10 times 10 is 100. On the outside, we get plus 60i, and on the inside, we got minus 60i, and last, we get minus 36i squared. But the plus 60i and the minus 60i in the middle add up to 0. This is really just 100 minus 36 times -1, so a minus times a minus is plus 36. And then the 100 plus the 36 is just 136. Notice what was going on here. We had two things that we were multiplying together, but they were almost exactly the same, except one had a minus and one had a plus. We call those conjugates of one another. So complex conjugates are complex numbers that have the same real part and the same imaginary part, except that one is negative and one is positive. And when you multiply those together, the I parts cancel, and the result is just a real number. And that's going to be the secret behind a trick that we're going to use when we do division. But first, one more multiplication example. What is 2 plus 5i squared? Remember, we're squaring this number, which means we're multiplying it times itself. We're taking 2 plus 5i times 2 plus 5i. So if we multiply that out, 2 times 2 is 4. On the outside, we have 2 times 5i, which is 10i. And on the inside, we get another 10i. And last, we get 5i times 5i, which is 25i squared. So we get the first thing squared, we get 2 of the first thing times the second thing, and we get the second thing squared. When we combine the I terms and rewrite the I squared as just -1, we get 4 plus 20i plus 25 times -1 is minus 25. And then combine the 4 minus 25 to get -21 plus 20i. So that's the answer. Now let's see how division works. I'm just going to do one of these because this is a little more complicated and I'm kind of making this a bonus topic. But what if we want to do 20 divided by 3 minus 5i? Or sorry, just 3 minus I. So we're taking one number, here it's just a real number, but it could be any complex number, divided by another complex number. The trick is we're allowed to multiply the numerator and denominator both by the same thing. And we're going to multiply by the conjugate of the denominator. This is pretty much the same trick that we used back when we were rationalizing denominators that had more than one term, but where one of them had a square root. Because that's really what's going on here. The I is really a square root. It's the square root of -1. So we're taking the 3 minus I, and we were multiplying by the conjugate 3 plus I. And whatever we multiply by on the bottom, we have to multiply by the same thing on top. So here's what we get. On top, the 20 times the 3 plus I Well, 20 times 3 is 60, and 20 times I is 20I. So on top we have 60 plus 20I. And on the bottom, we get 3 times 3 is 9. On the outside, we have plus 3I, and on the inside, we have minus 3I, but those add up to 0. Those cancel out. And then the minus I times the plus I is minus I squared. But remember, I squared is really just -1. So we have 9 minus -1 on the bottom. And 9 minus -1 would be 10. That'd be the same as 9 plus +1, so that's 10. So now we're looking at 60 plus 20I all over 10. The 60 divided by 10 would be 6, plus the 20I divided by 10 would be 2I. So we end up with an answer of 6 plus 2I.